So in this video, we'll be talking about the most commonly used database architecture styles. If you are using RDBMS or any NoSQL database, most probably you will be using either of these styles, master slave or multi-master. So yeah, let's take a deep dive into it. Let's start the video. Database architecture style. Let's consider uh, the single server master. So in that case, that single server is responsible to handle all kind of requests like read and write. And if you have a number of users, those who are using your application, then you have only one choice. You can just scale it vertically. That means you can uh, take a bigger server which have more memory and more CPU and support that many requests. So in this way, this has obviously is not a good choice, because in here you have a single point of failure, and also you have a threshold where after that you cannot support more number of users. So that's where, to scale it, our database, to align with the number of requests, we have to use multiple servers. So one of the possibility is that you can use the master slave architecture style. So let's take a look into that. Master slave, we have two servers. One will be acting as a master and one will be acting as a server. This is the minimum master slave architecture style. We can have multiple slaves too, but let's first consider only the one slave pattern. So in this case, this particular database cluster with two servers will be supporting both read and write request. If, let's say, a write request is coming to this cluster, then there will be a kind of logic or a kind of orchestration layer. Uh, Most probably that will be coming with the database setup itself. So that will redirect your write request to the master, and master will write that data first into its server, and then will send a request to the slave as well. When this whole thing completes, I mean, the master also writes and the slave also writes, then after that, this transaction will be considered as a complete transaction. If anyhow master not able to write anything into the slave, then the entry that has been written into the master will also be rolled back. So in that case, the write transaction will be master plus slave. There is one problem here, that when you are writing something into the master, then there will be a kind of delay because of writing into the slave too. So suppose if 10 millisecond is the time taken by the master to write, then some kind of network delay here, and the 10 millisecond time taken by the slave also. So overall it can be around, maybe let's consider that 30 millisecond it will be going to take to just write any entry into the database. Similarly, now consider the read request. So if application is sending a read request, then this particular logic will be transferring that read request to the slave directly. So in that case, the master will be offloaded because of that logic, and only responsibility of master in that case is to serve write request. The read request will be served by the slave. Suppose you have a 300,000 request coming per second, okay, and these 300,000 requests is a combination of read as well as write. Now this particular system will be able to support read and write requests, but out of these read and write requests, suppose 100,000 are only write request and remaining are the read request. So these 100,000 requests will be served by this master, and remaining 200,000 will be served by the slave. Now it only depends on the capacity of these individual server, how much they can handle. So here we have a threshold that we cannot go beyond 100,000 until unless we scale it vertically. That means we add more CPU and more memory. But in case of slave, we can add more slave server too, right? So that 200,000 again will be divided among these many slaves. So we can go beyond 2 as well. There is no restriction as such. But the only thing that is going to hamper your database performance is that your master will now be responsible to write into each and every slave first, and then it can commit this transaction. So earlier it was taking 30 milliseconds to complete a transaction between master and one slave. Now as you add more and more slave, that write transaction time will also be increased. So the problem here is you can write, but the time will be more in case there are many slaves. But yeah, the read request will be served in no time. Obviously it will be it is going to decrease because you have many slaves. So you can use that scaling power of slaves, and you can serve your read transaction by this style. So I hope you got the thing that this particular style is more suitable where your application is more read intensive compared to the write. Okay, so now let's consider another pattern or another style, architecture style, like master and master, multi-master system. Here instead of having a slave, we will be having multiple masters. So this is a very minimal uh, design where I have considered only two masters, but in actual world it can be many. So if we have multi-master system, then probably by now you got the concept that here both the server can handle read as well as write request, right? So responsibility of each individual master is to send that transaction to other master too. I mean, if let's say a request for write is coming to one master, then it will be the responsibility of this master to send that request, the write request, to other master and make sure that both are in sync. Again, the time taken by write transaction will be a combination of the individual. So again, I'm considering the 10 millisecond taken by this and the 10 millisecond taken by this and some kind of network delay also. Then it can be the write transaction might be taking around 30 milliseconds. So there is no as such improvement, but yeah, the time wise there is no improvement, but your both server can serve the write request. So if there are many write requests are coming and your system or your application is very write intensive, then you can leverage this pattern and you can introduce more and more masters. But yeah, that is going to increase. Okay, so we have solved one problem using this multi-master concept, that the time taken is obviously on a higher side and there is no improvement on the write transaction duration, but at least we can serve way more requests compared to a single master. So earlier, let's say it was taking only capable of only serving 100,000 write requests. Now it can serve 200,000 requests because we are using two masters. But there is one more problem introduced due to using multiple master, that now it's a responsibility of this database cluster to make sure that both masters are in sync. Suppose your application become very popular and your application have multiple instances across the globe. So in that case, there might be a possibility that number of users using the same data set into your database cluster. So if there are simultaneous write requests are coming from number of instances, and one application is sending request to M1 and one application instance is sending request to M2 at the same time, then there can be a conflict between the two because both are trying to write on the same data, and it can result into a conflict between them by syncing the data in between among each other. So the solution is that we can use the sharding here. So individual master here will be responsible to handle or will be the owner of a particular set of data set. So if a customer data is present among these two databases, then M1 will be responsible to handle, let's say, A to M uh, names, uh, customer names, and M2 will be responsible for N to Z. So this way we can shard the data set among these two servers, and if any request is coming to any of these applications depending on these initials, the request will be forwarded to the corresponding database. So this is possible via sharding, that we can avoid that conflict among these individual masters using sharding. But the thing is, in case of a relational database, this problem is little tricky, because if you have only single table, then it will work fine. But if this customer table is depending on any other table too, let's say organization, salary, or maybe something else, I don't know, it can be anything. Okay, so in those cases you have to also ensure that those particular related data is also present with M1, and that's where it started to become little tricky, or I would say very tricky, because you cannot segregate the data for each and every table based on the user. So if your system is using lots of unions and joins, then this particular setup might not work for you. So most of the NoSQL databases where we are maintaining a complete data set into one document itself, in those cases we can use this kind of setup. So yeah, so that's it for this video. I hope you liked it. See you in next video. Thank you.